Okay, two apologies. First, that this sounds bad because I did not bring the headset with me to Boston. And second, that I have to do this at all, flight issues. So we're just going to start arithmetic sequences. You guys did several yesterday and had to decide if they were geometric or arithmetic. Arithmetic sequences are a very, very special kind. And it's really important for me that you get the idea that a sequence, just in general, and this is a repeat, but it's important to restate, a sequence is a function. And it's a special type of function. It's a function where the input, this is not looking good, but we're just going to go with it, a function where the input is a whole number, which we define, or we call, it's a position, which means it's a specific place where that term is going to be. An input is a whole number, and output is a value. And in an arithmetic sequence, specifically in an arithmetic sequence, the next term is obtained by adding a common difference. It's obtained by adding a common difference. And we're going to call that common difference D. And it's the number that we're going to add to get to the next sequence. So let's take a particular sequence. So I'm going to have the input be 1, 2, 3, 4, and the output is -2, 1, 4, and you can probably guess what the next one is, 7. This forms an arithmetic sequence where t of 1 is equal to -2, t of 2 is equal to 1, t of 3 is equal to 4, and t of 4 is equal to 7. We use the notation with the t with a subscript instead of doing ordered pairs, but it really means exactly the same thing. So this is the ordered pair 1, -2, this is the ordered pair 2, 1, this is the ordered pair 3, 4, and this is the ordered pair 4, 7. So that is an example of an arithmetic sequence. And you could keep this going forever, and you could keep this going forever if you wanted to. Okay, we're going to kind of skip and do an actual, a different arithmetic sequence. So I'm just going to put a little break line here. I'm going to call this Roman numeral 1. And we're going to kind of do a horizontal t-chart here, where my position, n, 1, 2, 3, 4, 5, 6, 7, and I'm going to put a little ... and put 11 here. And then we're going to put value, which is denoted t sub n. That's a little subscript of an n right there. And that's going to be -1, then 2. And if you know that this is an arithmetic sequence, this is enough to get the rest of the sequence. 5, 8, 11, 14, 17. And I'm curious if you could figure out what this would be. I'm going to wait for it. You can pause this. I'm not going to wait too long. 8 would be 20, 9 would be 23, 10 would be 26, and 11 would be 29. It shouldn't take me too much work to get there. And you get to each successive term by adding 3. Plus 3, plus 3. This means that the common difference is equal to 3. And we can obtain this common difference by taking t sub 2 minus t sub 1, which will be equal to 2 minus the -1, which is 3. I can do t sub 3 minus t sub 2, which is 5 minus 2, or 3. I can do t sub 4 minus t sub 3, which is 8 minus 5, which is also 3. You get the idea. We could keep going with that forever. But that is how you obtain the common difference. You take a term and you subtract it from the one that came before. Okay. Second example, Roman numeral 2. I'm going to give the sequence 7, 4.5, and 3. Now, I apologize, you're going to be hearing lots and lots and lots of airport sounding sounds. This is someone dragging a cart of water behind me. Anyway, wow, that's really loud. Okay. In any case, this is a sequence of 3 terms, and if you look at how I get from here to here, you're going to notice that I subtract 2.5, or sorry, not subtract 2.5, yeah, subtract 2.5, and then if I go from here to here, oops, that's not going to be an arithmetic sequence, so let's cut that out, let's make this be a 2. So minus 2.5, minus 2.5, and now we're okay. This is arithmetic, with a common difference equal to negative 2.5. Again, you can get that common difference by doing t sub 2 minus t sub 1, which is 4.5 minus 7, which is negative 2.5. You can also do t sub 3 minus t sub 2, which is 2 minus 4.5, which is also negative 2.5. So any of those are going to do this. Now, let's generalize. What we want to do is we want to find a formula that inputs n and outputs t sub n. Well, if I want a formula that inputs n and outputs t sub n, I know that t of 1 is equal to 7. I'm going to start with that. And I know that t of 2 is equal to 7 plus the common difference, which was negative 2.5. Now, I know that, but I'm not going to put that right away. That 7 was t of 1 plus d. Now, if I did t of 3, that's equal to t of 1 plus d plus another d, which is equal to t of 1 plus 2d's. T of 4 would have to be equal to t of 1 plus 3d's. T of 5 would have to be equal to t of 1 plus 4d's. You get where I'm going with this. If I skip all the way now to t of n, that has to be equal to t of 1 plus n minus 1 d's, because the relationship between n and n minus 1 is the same as 5 to 4, 4 to 3, 3 to 2, and 2 to 1. There's an invisible 1 right there. So this is a formula that you are going to have to memorize. T of n is equal to t of 1 plus n minus 1 times the common difference. That is the general form for arithmetic sequence. And of all the formulas we're going to use in this chapter, this is one of the major 4 formulas. Okay, I'm going to put a break line here, and let's go on to, actually we're going to keep with this example, so let's call this Roman numeral 2 as well. And that's weird, kind of keep the same thing, but so if I say find t of n for 7, 4.5, and 2, and sometimes I'm going to put commas between them. Well, that is right up above. We're just going to take t of n is equal to t of 1, which is 7, plus n minus 1 times the common difference, and the common difference was negative 2.5. Now, we're not going to leave it like that. We're going to simplify 7 plus, which would actually be minus, we're going to distribute 2.5n plus 2.5, which is equal to 9.5 minus 2.5n. Or if I put that in linear form, negative 2.5n plus 9.5. One of these days you guys are going to remember me as the teacher who just couldn't let you guys have a day off. Okay, in any case, this is an example of now finding a general formula. So I want you to think about this as being the formula for the sequence 7, 4.52. So this is a way to say, here's a sequence, and if I put a dot, 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 I mean the sequence goes on forever. But this is a formula which is so much more valuable in math, because let's say I wanted to find T11, the 11th term. So if I wanted to find T of 11, I could say negative 2.5 times 11 plus 9.5. Well, negative 2.5 times 11, 25 times 11 is 275. So this would be negative 27.5 plus 9.5, which is really a subtraction problem, and that would give me negative 18. So that means the 11th term was negative 18. A formula can give you any term that you want. I could ask you the question, is negative 375.5 part of this sequence? And we could say, okay, so I'm going to let negative 375.5 be equal to this formula, negative 2.5n plus 9.5. Subtract 9.5 from both sides, you're going to get negative 385 equals negative 2.5n. Divide both sides. Well, we don't have a calculator. I'm pretending that you don't, because I don't. I'm sitting here in an airport. So I'm going to multiply both sides by 2. I get negative 770. I'm going to multiply by negative 2. 770 equals 5n. Boom, that is enough to say yes, because I know that 770 divides 5n, or divides 5. Josh just took a picture of me recording this for all of you. I'm not showing it to you. My final question could actually be the next extension of this and say, what term is negative 375.5? So if I want to know that, I'm just going to go 770 divided by 5 is equal to n, which means that n is equal to 14. So that means that, no, so n is not 14. N would be 154. So that means that negative 375.5 is the 154th term. See how valuable that formula is? There are a lot of questions we can answer. Okay, next break line, and we're going to go on to problem 3. Find T of 20 if T of 2 is equal to 13 and T of 5 is equal to 22. I know that many of you can guess and check this. I'm saying this a third time. I know that many of you can guess and check this. Guess how few points you're going to get if you just put down an answer and say, I did it in my head. That has never worked for math students in the history of time, and it will not work for you. So we're going to start with a general formula. T of n is equal to T of 1 plus n minus 1 times d. What I'm going to do is basically set up a system of equations. I know that this is the ordered pair 2, 13, and this is the ordered pair 5, 22. So we're going to use knowledge that we've done before, that prior knowledge thing, and we're going to build an equation. I should not call it equation 1. We'll do like one like that. So 13 is equal to T of 1 plus robocall n minus 1 times d, and then we're going to do equation 2, which is going to be 22 is equal to T of 1 plus 5 minus 1 times d. Alright, let's simplify both these equations. 13 is equal to, this would be 2d, or not 2d, sorry, this would be T of 1 plus d, and this would be 22 is equal to T of 1 plus 4d. We have a system of two equations with two unknowns. Pick your your favorite method, I'm going to pick elimination. So I'm going to do 22 is equal to t of 1 plus 4d, and I'm going to do negative 13 is equal to negative t of 1 minus d on top of each other. Add, and I get 9 is equal to 3d, or d is equal to 3. If d is equal to 3, that means that t of 1, let's just go to this one here, t of 1 would have to be equal to 10. If t of 1 is equal to 10, then the general formula is now t of n is equal to t of 1 plus n minus 1 d. Well, let's substitute what we know now. T of n is equal to 10 plus n minus 1 times 3. And if I simplify that, I get 3n plus 7. A lot of work just to get the general formula, but now I can answer any question it wants. It wanted t of 20. Again, going back way up to the top, we now wanted t of 20. T of 20 is equal to 3 times 20 plus 7, which is 67. So what makes this chapter so difficult for students is that this was a mega multi-part problem. We first started with two-ordered pairs and created a system of equations and solved that system of equations to figure out what t of 1 and d were, those two variables. We then did the second step and used that to figure out what the general formula was. Finally, we used the general formula to figure out what the 20th term was. So that's in essence what makes this chapter so challenging. You have to be a really adept. Adept is a word that means a student. A student is a word that means very skilled at multi-step problems. Okay, let's go down. Let's do number 4. Insert 2 arithmetic means between 18 and 53. Sometimes I feel like students tend to just look at a question, not know what it's asking, and not try something. This problem, if I wanted to insert 2 arithmetic means, it's using stuff we just did. So I would say what that means is doing 18 blank blank and 53. Now, this process is really easy if I have an odd number of blanks. And I'll leave it to you to figure out why. You can use the method we're about to use if there are an odd number of blanks, but there's an even easier method if there's an odd number. But it's not that it's not that easy if there is an even number of blanks. Okay, what I'm going to do is take this, and we're just going to call that t of 1, and I'm going to call that t of 4. So I've now generated the ordered pair 1, 18, and 4, 53. Well, I can take the general form of the equation, t of n is equal to t of 1 plus n minus 1 times d. I can substitute this ordered pair into that equation. So 53 is equal to t of 1 plus 4 minus 1 times d. But I also know what t of 1 is. I know that t of 1 is, I am being really picky with my highlighters, t of 1 is this 18. So if I know t of 1 is 18, that means I can actually write 53 is equal to 18 plus 4 minus 1 is 3, so 3d. And I know 53 does not divide 3, but that's okay. Subtract 18, 35 is equal to 3d, and d is equal to 35 thirds. Well, if d is 35 thirds, that is, I know it's I never said never to do this, but that is actually the mixed number 11 and 2/3. That's a trash cart going by. Let's see if this works. We're going to take this and plug it way back up here. So let's add 11 and 2/3. 18 plus 11 and 2/3 is 29 and 2/3. And then if I add 29 and 2/3 to 11 and 2/3, I get 41 and 1/3. And then add another 11 and 2/3 and I get 53. So my continuity among all those terms was maintained because I have the correct common difference. So first we find a common difference, and then we apply it on the sequence above. Okay, last question. Number 5. How many multiples of 6 are in between 79 and 1005? Well, we're going to do this by generating a sequence. We're going to do it by generating a sequence of multiples of 6. So the first multiple of 6 after 79 would have to be a multiple of 3 and a multiple of 2. Well, 81 is a multiple of 3, but it's not a multiple of 2. That would be 84. So I'm going to create 84, blank, blank, so many blanks, and then we're going to finish it with what is the last multiple of 6 before 1005. Remember, I'm in between these two numbers, but my numbers need to be counted as multiples of 6. So 1005 is a multiple of 3, but it's not a multiple of 2. So the one right before that would be 1002. So this is the sequence that I'm generating, and I'm now just changing what the question is that I'm actually asking. I'm saying 81 is t of 1, and 1002 is t of what? What is my value here? T of what? So if it's t of what, then let's figure out what a term. Well, I can answer that if I actually know what the general formula is for the sequence. Well, if I'm going to generate the sequence, my next multiple of 6 would be 90, and my next one would be 96. That is a common difference of 6. And I know that t of 1 is 84. That's enough information to get the general formula, because t of n is equal to t of 1 plus n minus 1 times d is my general formula. So 84 is equal to t of 1, which is, not 84, t of something, I don't know what that is, but I want to figure out what that question mark is. So let's make 1002 be my t of n. That way I can solve for n and know what that question mark is. T of 1 is 84 plus n minus 1 times 6. Okay, well, you can go forth and subtract 84 if you want. I'm going to divide both sides by 6 right now because I can. So 1002 divided by 6, and I'm doing this long ways because I don't have a calculator right here. Not that I need it. 6, 42, 7. This is 167 is equal to 14 plus n minus 1. And if I add 14 and then subtract, I get 154 is equal to n. So there are 154 multiples of 6 between those two numbers, what were they, 79 and 1005. Also note so that's not a question mark, that's a statement. Note that they're the same number of multiples of 6 between 84 and 1002 inclusive. Okay, so that was the word multiples, I just abbreviated. Alright, that's it. Your homework is on the calendar, and I will see you guys hopefully either later today or tomorrow.